Hi guys, how are you? You there? Hello. Are you able to hear me?
Yes, sir.
Yeah. Who are there? Gurman. Then I can see Chitij. Chitij, you're there?
Yes, sir.
And who's El Sarang and Soumya? So we were doing inequalities, isn't it? So could you get a chance to solve those questions, guys? You could solve any of them? Hello. Tell me. Yes, no, don't know.
Sir, I had the doubts in the last two of the worksheet.
How many could you solve, Gurman?
1 minute, I'll just see. I didn't get 4 of them.
4 of out of 10. How
Yeah.
many did I post?
Um,
Sir, 6.
No, more than that.
11. 11.
11. So you could solve. Yeah, Soumya, how many could you solve? Are you able to see the screen now, guys?
Sir, I solved 4 of them.
You solved 4. Okay. And what about others? Chitij, how many? Sarang? Hello, Sarang?
Sir, 4.
4 you could solve?
Yeah.
Or you attempted? There's difference between solving and attempting.
No, I solved.
You solved. And Sarang?
And not through the cheap methods.
Oh, not through cheap methods.
Yeah.
Okay. What about others? Who else is there? I can see Gurman only, Chitij, and what Sarang. Sarang is there. Sarang, you there? Can you hear me?
Sir, by mistake, he left the call.
Oh, okay. Never mind. So he'll join. So let's carry on, guys. And those who have done quadratic polynomials, they would be aware of something called discriminant, isn't it? So today we will have this another session on inequalities where we will learn some more inequalities and the theorems, right? So first is today's this thing is quadratic inequality. Okay, so quadratic inequality. So for those questions you could not solve, you can tell me the numbers later on. I'll send you the solutions. Okay, so quadratic inequality. What do we know? We know that quadratic equation is of the form of ax square plus bx plus c equals to 0, isn't it? Where a, b, and c all are real numbers. All are real numbers, and a is not equal to 0. And for this quadratic equation to have real roots, what do we know? We know that discriminant d is equal to b square minus 4ac. Right? This discriminant must be greater than or equal to 0 for real and unequal roots. Okay. And what else? Let us say if I have a polynomial like y is equal to ax square plus bx plus c. Okay. So hence y is always greater than or equal to 0 if discriminant is less than or equal to 0. Okay. So this is a property of, let us say, a quadratic polynomial. Let us say this is my x, and I'm drawing the x and y axis. This is x, this is y. Okay, and we had, let us say, this equation. This polynomial has this kind of a let's say graphical representation. So if you see, what is this? This this particular curve is y is equal to y, just yeah, y is equal to ax square plus bx plus c. So if this polynomial is greater than equal to 0, the condition would be that discriminant must be less than equal to 0. Okay, so basis this is a, and let us say if the curve is something like that. So most of you I have taught already in the class that for this case a is greater than 0, and for this case a must be less than 0. Okay, so now you can see in this case also, if there is a quadratic polynomial whose a is less than 0 and discriminant is also less than 0, then this particular y will always be less than 0. Can you see this? Y is always less than 0. In this case, y is greater than 0. Right. So these are all inequalities, right? So hence, let us solve one problem. The problem is given that question. Try to solve this. That a is greater than equal to b is greater than equal to c. Let us say this is given, right? Where a, b, and c all are real numbers. Now prove that a square plus AC plus C square is greater than equal to thrice of B and then A minus B plus C. Can you try to prove this? Try for 2 minutes and let me see if you can prove it. Did you get the question? So A, B, and C are real numbers such that A is greater than equal to B is greater than equal to C. Prove that A square plus AC plus C square is greater than equal to 3B times A minus B plus C. So hint is you have to use quadratic inequality. Any breakthrough? Yes, guys. Any? So another hint is try to write this as a quadratic in one of the variables, and then try to find out the d and see what happens. Another hint. Try to, as I told you, express in terms of one variable and form a quadratic equation and then. Gurman, right? Done.
No, sir.
Why are you clicking so many times?
Sir, there was a notification, so I was just switching it off.
Oh. Hmm. So now, okay. Anyone? Chitish, you could do it.
No, sir.
Try to find out. Try to frame a quadratic equation in one of the variables. Do you see a quadratic equation here?
Yeah.
Yeah. Who else is there? I can see. Sarang has joined. Sarang is there.
Yes, sir.
Hello. Are you there? Could you
Yes,
try
sir.
this one? Yeah. Any breakthrough in this question?
Sir, I'm trying it, sir.
See, in such cases, guys, it was clearly evident that you had to use something called quadratic inequality. What is that? So let me just rewrite this inequality. It is a square plus ac plus c square. Okay. And this is greater than or equal to what? It is 3ab minus 3b square plus 3bc. Isn't it? Now let us write this such a way that all the terms are in on one side. So hence I can write this as a square plus ac plus c square plus 3b square minus 3ab and minus 3bc, and this must be greater than or equal to 0. Okay. So if you see, there are which term should I go for? I can, and you have square term in a as well, square term in b as well, and square term in c as well. Okay. So but if you see, b has more and for that matter, you could have taken any of the three as, but they, yeah, a square, b square, c square, all are there. So what I can do is, let me rewrite in terms of b square. So 3b square, then what? I can take minus 3b as common, and this is a plus c. And what is left? Left is plus a square plus ac plus c square, and this must be equal to 0. This is what it is left with, isn't it? So if you treat it as a quadratic in b, so discriminant d will be b square. What is b square here, guys? Minus 3a plus c. This is b here in this case, b square minus 4 into 3b square. Okay, into what's next? 3b square into a square plus ac plus c square. You get this? This is the discriminant. Now let us try and
Why is
calculate
it
this. So this is
square?
nothing but, I'm sorry, come again. Sorry, I couldn't get you, Sarang. What did you say? So this is this minus 12b square times a square plus ac plus c square. Okay, so hence this is nothing but 9 times a square plus c square, then what, plus 2ac minus 12 a square b square minus 12 ac b square and minus 12 b square c square. Okay, so opening this up, you'll get 9a square plus 9c square plus 18 ac. Am I right? Looks like.
So B
Oh,
square
I'm
is
sorry. B square will not be
yeah.
there. I'm sorry. Sorry. B square is, yeah, this should not be there. Yes. So hence B square is gone. B square is gone. Yeah. Correct. So this is the final one. So hence this is minus 12a square minus 12 ac minus 12 c square. So this means what is left? Minus 3a square is left. Then what? Minus 3c square will be left. Then what? Plus 6ac is left. If I take 3 common, I'll get a minus 3 common. You'll get a square plus c square minus 2ac, right? Which is nothing but minus 3a minus c whole square, right? And which is clearly less than 0, less than equal to 0, less than equal to 0. Why equal to? Because A could be equal to C, right? So, right, this is less than 0. So discriminant is less than equal to 0. That means what? The expression must be greater than equal to 0, and hence this expression is true. Okay, did you understand? So if there is a quadratic polynomial, if the d is less than equal to 0, then the polynomial itself will be greater than equal to 0. This is what was the learning from this inequality, right? So moving ahead, next type of inequality is very famous one, and you know, most of you would be knowing, and this is am, gm, hm. Am is always greater than equal to gm, is always greater than equal to hm, right? So hence we call it arithmetic mean, arith arithmetic mean of anything. We'll define all of them. Is greater than geometric mean is greater than equal to harmonic mean, and equality holds when numbers are equal. Harmonic mean. Okay, so what is am of two numbers? Am of a1 and a2 is nothing but, what is am? Nothing but a1 plus a2 by 2. Okay, this is for two numbers. Okay, in gm, geometric mean of a1 a2 will be, a1 a2 will be nothing but a1 a2 multiplied whole to the power half, which is nothing but root of a1 a2. This is called geometric mean. And harmonic mean of a1 a2 is given by, harmonic mean is given by 1 upon 2, 1 upon a1 plus 1 upon a2, right? And this can be generalized for many numbers as well, more than two numbers as well. So hence, what is it? Please remember, this is a very famous and very effective tool. am is greater than equal to gm is greater than hm. Okay, and let us say a1 a2, now generalizing for more numbers, a3, so on and so forth, an all belongs to the set of real numbers. Then my friend, then a1 plus a2 plus a3 plus dot dot plus an whole divided by n, this is the average or the arithmetic mean, is greater than equal to a1 a2 a3 dot dot an whole to the power 1 upon n. Nth root of this is greater than equal to 1 upon n, 1 upon 1 by a1. I'm sorry, not 1 upon a1. This is 1 upon n, 1 by a1 plus 1 by a2, 1 by a2. I'm sorry, this quantity is h. So hence, hold on, what I'm trying to, hm of a2 is, this is 1 upon, this is hm of a1 a2. Okay, 1 upon, right? So hm of a1, so basically 1 upon hm, harmonic mean, is nothing but 1 upon n, or one, in this case 1 upon 2, 1 upon 2, and this is 1 by a1 plus 1 by a2. This is 1 upon hm. So you can find out what is hm. Hm will be nothing but 1 upon this whole, isn't it? So hence that will be nothing but 2 by 1 by a1 plus 1 by a2 in this case. So here in this case will be, this one is nothing but n upon 1 by a1 plus 1 by a2 plus dot dot 1 by a. So please remember these inequalities. Okay, so now let us see some, and there are some more results basis am, gm, and hm inequality. What are these? We'll also learn that. So you can take down, these are very important inequalities. So a1, sorry, not a1, let us say a and b. So I'm saying a1 or a square plus b square plus ab will be greater than equal to 3 by 4 a plus b whole square. Okay, this is one of the inequality. Okay, this is also called Sophie inequality. Sophie inequality.
Same person made the Sophie Germain thing.
Yeah. Okay, so you have to take down these inequalities and keep them, so that you can solve the questions a little quickly. So a square plus b square, again another equality, is minus ab is always greater than equal to ab. This is very easy to prove. Why? Because a square plus b square minus 2ab is always greater than 0. Why? Because a minus b whole square is always greater than equal to 0, right? So it follows direct from here. Then a cube plus b cube is greater than equal to ab a plus b. Can you prove this? Similarly, acha, let me just mention all of them. 1, 2, 3, 4. Fourth is a b by a plus b is less than equal to a plus b by 4. This also is easy. Why? Because a plus b whole square is a is greater than equal to 0, right? So what can I say? Minus 4ab, right? No. So a square plus b square plus 2ab plus 4ab, will it be greater than equal to 0? No. Minus 4. Hold on. How do you prove this? Can you prove this one? AB. So basically you have to prove that. What do you need to prove? You need to prove that a plus b whole square is greater than equal to 4ab. That means a square plus b square plus 2ab minus 4ab is greater than equal to 0, which is true. Why? Because this is nothing but a square plus b square minus 2ab is greater than equal to 0. Because a minus b whole square also is greater than equal to 0. So this holds. If this holds, then this holds. Correct. Then one more. There are lot many more these kind. Let us say this is a square plus b square by a plus b is greater than equal to a plus b by 2, and likewise many more. So now that you know the AMGM inequality and their varieties, let us delve into problem solving. Here is the first problem on this. Prove that or show that. Question is, if A, B, C, D are four positive real numbers, A, B, C, D, all belong to R, and A, B, C, D all are greater than 0. Okay, then prove that A by B plus B by C plus C by D plus D by A is greater than equal to 4. Prove. Direct application.
You gave this in the sheet.
Did I?
Yeah,
So did you arrive at the solution?
I didn't do this.
Now try. The right application, guys. Why are you taking so much of time? Hello.
Yes, sir.
Done? Not done.
Yes, sir.
So just a minute, sir. Sir, done.
Done?
Yeah.
All of you? How many? Hmm? See. Okay, so you see, very important that all of them are greater than 0. So hence, clearly A by B is greater than 0, and B by C is also greater than 0. C by D is also greater than 0, and D by A also greater than 0. Okay. So hence, AM of 4 number will be greater than equal to GM. So what is AM of all this? AM of all this will be A by B plus B by C plus C by D plus D by A. Sum of all of the 4 divided by 4. This is the arithmetic mean of this. This must be greater than equal to the GM. GM is nothing but what? Multiplication of all. So A by B into B by C into C by D into D by A whole to the power 1 upon 4. Right? So hence what do we get? Very easily. A by B plus B by C plus C by D plus D by A by 4 is greater than equal to 1. Hence, A by B plus B by C plus C by D plus D by A is greater than equal to 4.
I
Very
simplified it.
simplified. And what did you do after simplification?
I brought the 4 down. In the end, it comes to the same thing.
You brought the 4 down. So,
You
okay.
you simplify it,
Mm-hmm.
and then you get everything, some big value divided by A, B, C, D.
Mm-hmm.
So you bring A, B, C, D to the side of 4 and you bring 4 down. And then then you can see that if you multiply all the numbers in the numerator on the left hand side and then find fourth root, it's the geometric mean.
I couldn't get your solution, Shudesh.
So
Come again.
basically simplify everything.
Simplify means what? Take LCM and all that.
Yeah, that's what I did.
Okay, okay, fair enough. So you are saying simplify everything. So let's simplify. So you will be getting what?
A square
A
BC
square DC
plus B square AD
plus B square AD DA.
plus C square AB
C square you'll get
plus C square
uh,
AB
C square AB. Okay,
plus D
plus
square
D
BC
square D square
BC
BC. Yeah, divided by
divided by A
ABCD. Okay,
is greater than equal to 4.
right.
So
So
then like you bring ABCD on right hand side and 4 on left hand side.
so what you do is you take this. This is what you mean.
Yeah. So now if you multiply all the terms in numerator on left hand side and then find the fourth root, it's ABCD. So that way also it works.
I see. Okay, good. So what you're saying is there are 4 terms. This.
Yeah.
So arithmetic mean of that will be equal to or greater than equal to a square CD, and then there are how many a square? 2 more. So it all will be having. So if you multiply all, you will get A4, B4, C4, D4, and this to the power 1 by 4, which is ABCD. Right. Good. Good. Great. So let me now give you another one. Hmm. I have given you lot many in the sheet. Lot of them will be used to solve. Okay, so solve this question. Question is, if x and y are positive real numbers, or let us say a and b belong to r plus, okay, real numbers, then prove that 4a to the power 4 plus 4b to the power 4 plus 5a square plus b plus 1 is greater than 12ab. Yeah, prove this. 4a to the power 4 plus 4b to the power 4 plus 5a square plus a plus b plus 1 has to be more than 12ab. Again, hint is use AMGM.
Sir, is it 4a cube or 4a to the power 4?
A to the power 4, and then I'm sorry, this is b cube. Did I give this question to you?
No, I'm just asking because then it kind of makes sense. I thought it was 4a cube.
No. 4a to the power 4 plus 4b cube plus 5a square plus b plus 1. There's a pattern if you notice. A B. Hmm. I just need to see your think for some time and let me know. Any breakthrough? Yes, Kshitij, what are you thinking? Hmm. Guys, you're silent. Gurman?
Yes, sir.
Any thought process on this?
Sir, I'm trying to find the GM and the HM.
GM and HM of what? Why? GM of what? And there are lots of pluses, so why are you not going for AM?
Oh, yeah.
Hmm? Yes. The other people, Sarang, you're there or not? Hello, Kshitij?
I'm
Yeah.
there, sir. 1 minute,
Anything?
sir.
Any breakthrough?
No, sir.
Let me solve now, guys. Now, could you solve? Anyway, see again how to apply AMGM here. So we will see. This is one thing which is yeah, this one and this one is going to be little we'll club them, and this one is going to be clubbed together. Let us see how does it work. So if you see 4a to the power 4, okay, plus 1, 4a to the power 4 plus 1 is certainly greater than equal to, let us say, this by 2 is greater than 4a4 into 1 square root, isn't it? Which is equal to, this one is nothing but 4a to the power 4 plus 1 is greater than 2 times 2a. So hence we can say 2a square. So 4a to the power 4 plus 1 is greater than 4a square. Can you see something now? Okay, so this is one AM by AMG inequality. Similarly, if I say 4b cube plus b, 4b cube plus b by 2 is going to be greater than equal to 4b cube into b square root, right? So hence it is 4b cube plus b by 2 is greater than equal to 2b square. So hence 4b cube plus b is greater than equal to 4b square. Is it okay, guys? So that means the given expression was 4a4 plus 4b cube plus 5, what was it, 5a square plus b, 5a square plus b plus 1 can be written as greater than equal to. So now if you club these two, there is 5a square here, so I can take out 4 from there, isn't it? So hence I can write that this is equal to sorry, so if you see these two together, so this is greater than equal to what? This is greater than equal to 4a square, and 4b cube and b is greater than equal to 4b square, and 5a square is left alone. So hence it is nothing but this is equal to 9a square plus 4b square, isn't it? This is 9a square plus b. Now again, if you see 9a square plus 4b square by 2 will be greater than equal to 9a square into 4b square square root, which is nothing but 9 4 is 36, so 6ab. So hence what do I get? 9a square plus 4b square is greater than equal to 12ab. Correct? This is what? 12ab. This is what you have to prove, right? So this entity here is eventually greater than 12ab. That is what you are supposed to find, prove. So hence prove. Okay, so you have to be, this is where is the conventional, that is what you do in school, right? It is unconventional. So you have to think. Obviously it will take some time, so don't lose heart, but then you have to spend time and explore a lot. Okay, so I'll be again, I've already given you some questions. Now I'll be moving further and now I'm going to give you another theorem which is called weighted means. So weighted means, you have to keep all these theorems and concepts at one place to be able to apply all these. Okay, so given any n positive real numbers, so there are n positive real numbers. Okay, there are n positive real numbers, then a1, a2, let us say these are all real positive real numbers, please understand, right? And let us say w1, w2, w3 are all positive weights. What is positive weights? I'll tell you. Positive weights. So for example, in your exam, in your 10th board, you have some, let us say 20% weightage is of internals and 80% is of the exam. So these are called weightages. 0.2 and 0.8 are the weightages. So let us say you got 50 out of 100 in internals, and let us say 80 out of 100 in the final paper. So hence your total score will be 20% of 50, that is 20% of 50. Okay, and 80% of 80, and this is out of 200, or this is out of 100. So hence how much is it? So 20% of 50 is 10, and 80% of 80 is 64. So you got how much? 74 out of 100. Yeah, if you would have got 50 out of 100 in internal and 80 out of 100 in the final paper, so you will be getting 74 out of 100 in the final score. So this is weight. So what did I do? I multiplied 0.2 into 50, your score, plus then 0.8 into the second score, and then the total score I took. Okay, so this is how yeah, so this is what you will be getting in the final exam. So this is what the concept of weight is. So now let us say there are a1, a2, an numbers, and w1, w2, w3, and wn are weightages. Then if I define a as, let us say a as a1 w1 plus a2 w2 plus a3 w3, like that, so on and so forth, and this is an wm, right? This is weighted arithmetic mean. This is called weighted arithmetic mean. Not it will be not it will not be n, it will be a1 plus, sorry, it will be w1 plus w2 plus w3 plus w4 plus dot 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 wn. So if you see here that we have to divide by 20 plus 80 weights were, or zero point 0.2 by 0.8, 0.2 0.2 plus 0.8. So that's what you have to divide. So here it will be 0.2 and 0.8. These were the weights here, right? So this is a, and then let us define g. And what is g? G is nothing but a1 to the power w1 times a2 to the power w2 times so on and so forth an to the power wn whole to the power 1 upon w1 plus w2 and all that. So I'll write like this. So this is 1 upon, power is 1 upon w1 plus w2 plus dot dot wn. If this is g, and h is defined as w1 plus w2 plus dot dot wn divided by w1 upon a1 plus w2 upon a2 plus dot dot wn upon an. These are the three a, g, and h I found out. So in this case also a is greater than equal to g is greater than equal to h. This is weighted means. This is the concept of weighted means. Okay. So let me give you a few more theorems before we actually solve some more problems on that. So now let me give you this. What is power mean inequality? This is, what did we learn? This is weighted means inequality. So this is one, and then now it is something called power mean inequality. So power mean inequality.
So could you scroll up?
Scroll up. Yep. You're writing now, is it?
Yes, sir. Yes, sir. Thank you, sir.
Yeah. Now, power mean inequality. What is it? So again, we are dealing with positive numbers a1, a2, an. All belongs to r plus. Okay. And w1, w2, comma wn, all again are non-zero real numbers. Sorry, all are again are positive real numbers, and let us say m be a non-zero real number. Okay, then power mean wpm for m is given as nothing but weighted mean of all. So let us say this is w1 a1 to the power m plus w2 a2 to the power m plus so on and so forth plus wn an to the power m divided by all the weights W1 plus W2 dot dot Wn, and this whole 1 by m. Okay, this is defined as WPM, power mean of any n numbers like that. Okay, so hence let us say if there are two numbers p and q such that p is greater than q, then WPM of p will be greater than WPM of q. This is another inequality. Okay, and I'll take an example and show you. Okay,
So is the bracket for the numerator only or the numerator and denominator?
full.
Okay.
Okay, let us take an example and see the application of power mean inequality. Okay, so what is the application? Application is prove that a to the power 4 plus b to the power 4 plus c to the power 4 is greater than equal to a b c, a plus b plus c. Okay, and it is given that a, b and c all belongs to positive real number set. So how to prove that? So let us now try to find out weighted power. So weighted mean WPM4. What will be WPM4? So WPM4 will be when weight is, let us say, 1. All the weights are 1. So hence you can say WPM4 is a, let us say all the weights are 1. Okay, so how do I formulate this? So let me first write. So let us say a b c are three numbers all greater than equal to 0. Then let us say w1 w2 w3 weights, or in this case not 1 2 3, in this case the weights are a b and c. So weight of a is, let us say, wa, weight of b is, let's say, wb, and weight of c is wc. All are equal to 1. Okay, so now see here. So one is the, so in this case if I just now put all these values, so let us say WPM 4 will be nothing but 1 times a to the power 4 plus 1 times b to the power 4 plus 1 times c to the power 4 divided by 1 plus 1 plus 1 and whole to the power 1 upon 4. This is WPM4, correct? Now what will be WPM1? WPM1 will be 1 times a to the power 1 plus 1 times b to the power 1 plus 1 times c to the power 1 divided by 1 plus 1 plus 1 whole to the power 1 upon 1. Isn't it? Now, by the inequality which we just learned, WPM4, if 4 is greater than 1, then WPM4 will be greater than WPM1. In fact, greater than equal to, if guys, just excuse me for a minute. I am getting some urgent call. Yeah, sorry guys. So hence we were here. Yes. So hence WPM is greater than equal to. So the inequality is, so P is greater than equal to, this is greater than equal to. So WPM is greater than equal to WPM1. Okay. Oh, so you are not getting the just that. Just a minute, got hung. What happened? Just a minute, guys. I have to do some arrangements. Yes. Just just a minute. Yeah. Sorry for the inconvenience. So this is what. Yeah. So WPM is greater than equal to WPM1. This is what we learned. And now we will be applying. So hence, if you apply this, what do you get? You get what? So let me write that. So a to the power 4 plus b to the power 4 plus c to the power 4 divided by 3 whole to the power 1 upon 4 will be greater than equal to a plus b plus c by 3. Isn't it? A plus b by c by 3. Now, if you raise both sides to the power 4, you will get a4 b4 plus c4 divided by 3 is greater than equal to a plus b plus c by 3 whole to the power 4. Isn't it? Correct? So that means now this can be simplified as, so what was our target? So we need one a b c and a plus b plus c. So let a plus b, one a plus b plus c come out of it. So hence you can say this is the right hand side, or the left right hand side is a plus b plus c by 3 times a plus b plus c by 3 to the power 3. Okay, right? Now a plus b plus c, a plus b plus c, a plus b plus c by 3, what is it? It is giving me an indication of am of a b and c that will be greater than equal to a b c to the power 1 by 3. Yes or no? Right? So
Yes,
hence
sir.
if you raise both sides, a plus b by 3 to the power 3 will be greater than equal to abc. Yes. Yes. So hence what do I get? I get on the this particular side will become what? This will become, this is now greater than equal to a plus b plus c by 3, and this is a plus b plus c by whole by 3 whole to the power 3 is greater than abc, so I can multiply this by abc, isn't it? So that means this is greater than a plus b by yeah, so hence what do I get at the end of the day? I get here, this one we started from So hence it is a to the power 4 plus b to the power 4 plus c to the power 4 by 3 is greater than equal to a plus b plus c by 3 times ABC. So this 3 and this 3 gets cancelled. So hence we get the desired inequality. Okay. So you can try other methods also. Other methods also can fetch you the same result. But this is an application of weighted, what is that? Power mean inequality. So this is okay. Moving ahead then, there are some more important inequalities, and one is, and now the one which we are going to discuss is also very important and very famous, and this is called chef by chef inequality. Okay, this was a Russian guy who gave this inequality, and it's called chef 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 by chefs, chef by chefs, chef by chefs inequality. So last time we saw Weierstrass inequality. Now this is chef by chefs inequality, and it says let xi yi belongs to R. Okay, for every I is equal to 1 2 till n. What does it mean? It means simply that x1 x2 x3, so I is equal to 1 2 3 like that, xn, and y1 y, this is another way of writing this, y2 y3 dot 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 yn. These are all real numbers such that x1 is greater than less than equal to x2 is less than equal to x3 less than equal to dot 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 xn, and y1 is less than equal to y2 is less than equal to y3 is less than equal to dot 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 in. Then what is this inequality? x1 yn plus x2 yn minus 1 plus dot 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 plus x3y, sorry, not x, last will be xn. So this is xn y1, right? This whole divided by n is less than equal to x1 plus x2 plus dot 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 plus xn whole divided by n, that is arithmetic mean of xi's, and similarly y1 plus y2 plus dot dot yn divided by n, so arithmetic mean of y, and this whole is less than equal to x1 y1 plus x2 y2 plus x3 y3 plus dot 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 xn yn divided by n. Okay, this is what is called Chebyshev's inequality. Okay, now,
So
yep.
for the second part of the inequality, is it x1 x plus x2 plus xn all that into y1 plus y2 plus yn by n?
Yes.
Okay.
So this one is x1 summation xi divided by n. This is summation yi divided by n multiplication.
Okay.
Okay. So now let us understood this is Chebyshev's inequality. Now keep this inequality in front of you and try to solve this one. Okay. If A, B, and C belongs to R plus, all are positive. This is question on basis this. Then prove that A to the power 8 plus B to the power 8 plus C to the power 8 divided by A cube, B cube, C cube is greater than equal to 1 by A plus 1 by B plus 1 by C. Prove it. Prove it. So you'll have to apply Chebyshev's. Just a minute. Guys, what happened? Any luck? Hello? Yes. Siddesh?
Yes, sir.
What happened? No clue. No clue. Okay, I'll give you a hint. What does chef by chef say? So you have to have two X eyes and Y eyes first of all, isn't it? So if you take the first half of this is very vital. So let us say if I take xi is equal to a to the power 6 and yi is equal to, let us say, a to the power 2, like that, xi yi. And similarly, so x1 you can consider, so x1 is equal to a to the power 6 and y1 is equal to, let us say, a squared. Similarly, x2 you can consider b to the power 6 and y2 is equal to, let's say, b square. And then third is x3 is equal to, let us say, c to the power 6 and y3 is equal to c square. Now check this part of the chef by chefs, the chef by chefs right hand side, the two extremes, right? So sorry, the second and third term, what does it mean? It says, let us say if n is equal to 3, so x1 y1 plus x2 y2 plus x3 y3 divided by 3. Okay, this is greater than equal to what? x1 plus x2 plus x3 by 3 whole into y1 plus y2 plus y3 divided by 3, isn't it? Yes, so this is what we would have gotten. So hence, if you see now on the left hand side, x1 into y1 will be nothing but a to the power 8, and then second term is b to the power, sorry, b to the power 8, yes, and third term is nothing but c to the power 8 divided by 3 divided by 3. And that is equal to, greater than equal to, that is greater than equal to x1 plus x2 plus x3. So what do I get here? Here we get a to the power 6 plus b to the power 6 plus c to the power 6, right? And this is this divided by 3, okay, and then multiplied by this a square plus b square plus c square divided by 3, isn't it? That means, what do I get? I can say that 1 3 is cancelled, 1 3 will be cancelled, so this is cancelled, this 3 will be cancelled. So eventually the inequality becomes what? Inequality becomes 3 times a to the power 8 plus b to the power 8 plus c to the power 8 is greater than equal to, a to the power 6 plus b to the power 6 plus c to the power 6 times a square plus b square plus c square. Okay, this is what the first part of the inequality is. Somewhat, now we are getting a to the power 8 plus b to the power 8 plus c to the power 8. Now let us see whether we can go further. Now a to the power 6 plus b to the power 6 plus c to the power 6, guys. Okay, by AMGM inequality, what can we say? This by 3 is greater than equal to a6 b6 c6 whole to the power 1 by 3, which is nothing but a square b square c square. Okay, similarly what can we say is there is one one more step. So this is one thing which I didn't teach you, but anyways, please remember this, that a square plus b square plus c square, right? A square plus b square plus c square will be greater than ab plus bc plus ca. Why? Why will it be like that? Because if you see, um, a,
So
yeah,
a plus b plus c whole square is greater than 0.
yes. So if you multiply both sides by 2, so it will be like that. So hence you can see what you can say, that a square plus b square minus 2ab, then plus b square plus c square minus 2bc, plus c square plus a square minus 2ac. This whole should be greater than equal to 0. Why? All of them are squares. If you see, a minus b whole square plus b minus c whole square plus c minus a whole square is greater than 0. So from here it follows this, right? So what do I learn? I learn a square plus b square plus c square is greater than ab plus bc plus c, greater than equal to that. Yeah. Correct. Now a square plus b square is greater than ab plus bc plus ca, and what else I got? Yeah, and so there are two parts of this inequality here. This part, so if you take this 3 here, so it becomes 3a square b square plus c square. So you can cancel this 3, right? So that means a to the power 6, b to the power 6, c to the power 6 all added together is greater than this. And a square plus b square plus c square is greater than ab plus bc plus ca. That means this whole left hand side can be written as 3 times a to the power 8 plus b to the power 8 plus c to the power 8 is greater than equal to what? Is greater than 3 times a square b square c square times ab plus bc plus ca. So hence, if you see this 3 goes. So what is left? So this is what. So hence I get. What do I get? I get. Yeah. So this is. So from here I have to get AB plus BC plus C. Okay. So now what is the original inequality? Original inequality says divide it by A cube, B cube, C cube. The A8, B8, C8. So hence dividing both sides by A cube, B cube, C cube. You have to divide A cube, B cube, C cube. So hence the right hand side inequality is 1 by ABC divided by AB plus BC plus CA. Hence it is 1 by what? 1 by C plus 1 by A plus 1 by B. Isn't it? So the right hand side we arrived at whatever was required. C 1 by A plus 1 by B plus 1 by C. So hence this inequality is proved. Did you understand this, guys? Yeah. Did you understand how to apply Chebyshev's and multiple other together? Multiple other things.
Yes, sir.
So this is, please keep in mind, and this is how you have to, obviously you'll have to solve a lot of problem spaces. Then only you will be clear. So I'll be sending you some problems, and then you can apply them. Now another very famous inequality is Cauchy-Schwarz inequality. Okay, so what is that inequality? I'm writing it here. Cauchy-Schwarz inequality. Sorry. Cauchy-Schwarz inequality again. So this guy was a French guy, and this guy was again a German. So this guy was French, Cauchy. Schwarz was a German Prussian guy, and in early 19th and 20th century. Now, what is this inequality? Again, if A1, A2, A3, dot 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 AN, and B1, B2, B3, and Bn, right, are real numbers, then 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 what? A1 B1 plus A2 B2 plus dot 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 plus AN BN a and bn squared is less than equal to a1 squared plus a2 squared plus dot dot an squared into b1 squared plus b2 squared plus dot dot bn squared. Okay, and equality holds holds where does the equality holds only if a1 by b1 only if a1 by b1 is equal to a2 by b2 is equal to c2 by a3 by b3 is equal to all that an by bn. This is called Cauchy Schwarz inequality. So if you see the previous one, what was the any resemblance, some closeness? So Chebyshev's inequality was involving arithmetic mean and all that. There was no powers here, right? So hence arithmetic mean of two series all must be n. All n numbers were there, right? So x1, x2, x3, xn to be by n, and then y1 plus y2 plus yn. All this here we are talking about. In this particular step, these are am and two ams of two series of number is less than, if you see one product taken at a time. So x1 y1 corresponding elements if you multiply and then take the mean. So hence the multiplication mean will be more than the product of individual mean. This is interesting, and this is on the left hand side, it is the reverse order of multiplication. So this is there's no power here. Now here they talk about not means, here it is power, right? So again, multiplication of a1 b1 a2 b2 and all that whole square is less than equal to the sum of the square of the sum. Basically you can say the square of the sum is less than the product of sum of the squares. Okay, this is what in another way you can say. Now can you prove it? Can anyone try and prove this? How can this be proven?
If you use vectors, then it's the dot product, I think.
What is vector?
If you use a vector and multiply them, I think you get this inequality. I'll do it and let you know.
Yeah, try to prove this. Try and tell me how can this be proven, and then I'll give you the proof. Yeah.
Yes, sir, I got it, sir.
Yeah, tell me.
So if you take two vectors u and v, where u is a1 a2 a3 until an, and v is b1 b2 b3 until bn, and then the dot product of the vectors is the magnitude of u into the magnitude of v into cos theta. So that is that is less than equal to the magnitude of u into the magnitude of v. Like, so uv cos theta is less than uv.
Yeah. And so what you are trying to say is this, that I don't know if most of others are comfortable with vectors, but let us see. Let us say vector x is given by, let us say, a1 and it is n-dimensional vector, let us say. So a1 and or in terms of matrices also you can talk about, but let us say, but most of you would not be comfortable with the dot product thing, so hence let me not do it here. I'll give you some other this thing, but you are right, Sarang. So the magnitude of the magnitude of a vector and product of magnitudes of two vector will be greater than equal to the dot product of the vectors. Yeah, so that one way of doing that is this. Otherwise what you can do is this, that Yes. So again, we'll be using quadratic, inequality, right? So what will we do? So we are going to define a function is like this. So let us say fx is equal to I am writing a1x minus b1 whole square plus a2x minus b2 whole square plus dot 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 plus anx minus bn whole square. Okay, and do you think this is greater than equal to 0? Because all are sum of squares, isn't it? So if you open it up, what will you get? You'll get x square common, and within brackets you'll get a1 square plus a2 square plus dot dot an square, and then you will get minus 2x common, and within brackets you can write a1 b1 plus a2 b2 plus dot 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 an bn, and then final term is nothing but what? b1 square plus b2 square plus dot 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 bn square. Correct. And this is greater than equal to 0. So that means the discriminant of this must also be greater than equal to 0. Sorry, less than equal to 0. So hence, what is the discriminant here? So discriminant clearly is d is equal to a1 b1 plus a2 b2 plus dot 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 an bn, discriminant b square. So this is square minus 4 times ac. So ac will be a1 square plus a2 square plus dot 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 an square times
Sir,
b1 square. Sorry.
sir, I think you forgot coefficient -2 for b
Sorry.
square.
So this is 4, right? So b square, and then thanks for correcting, and then this is bn square, right? So this is my what? D, and this must be less than equal to 0. So hence it automatically proves the theorem. What is the theorem now? So hence a1 b1 plus a2 b2 plus dot 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 an bn whole square is less than equal to a1 square plus a2 square plus dot 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 an square times b1 square plus b2 square plus dot 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 bn square. Okay, so this proves the theorem. Now, okay, so let me give you a problem on this then. What? Okay. Just a minute. Which one should I give? A apply b plus b by c by a square by b. This is some Olympiad problem only. Let's try this. So question is this: if P1, P2, P2014. So you can guess this is a question of 2014. Be an arbitrary arrangement. Okay, so these are they are 2014 real numbers. Okay. Okay. Prove the inequality. 1 by P1 plus P2 plus 1 by P2 plus P3 plus 1 by P3 plus P4, so on and so forth, plus 1 upon. So this is a perfect RMO question 2013. So this is a perfect RMO question P2013 plus P2014, and this is greater than equal to 2013 by 2016. So your hint is you have to apply Cauchy Schwarz inequality. And the inequality is this, just above. Guys, one thing is, see, all these are 2014 real numbers, but all of them are from 1, 2, 3 to 2014. Okay, understood? So P1, P2, P3, P4 all are either 1, 2, 3 or something like that. So there are 2014 numbers, but which one is what is not known, but they are certainly 1, 2, 3 till 2014. So use that concept. Yeah. Hmm. Yes. Struggling. Yes, guys. Any idea? Hello? Hello?
Yes, sir.
Did you get anything?
No,
No.
sir.
Hmm.
1 minute, sir.
How many numbers are? Did you understand the question? The question is something like this. The question is 1, 2, 3, 4 till 2014. 1, 2, 3, 4 till 2014. These are the numbers, okay? And all these numbers are any. So let's say this one, if this P4 is P1, then this is P2, then this is P3, like that. So there are 2014 such numbers ranging from 1 to 2014. Now you have to find out, you have to prove this inequality. So, and I told you that Cauchy Schwarz can be applied. So see here, P1 plus P2, what I'm saying is P1 plus P2, P1 plus P2, okay? Let us observe these numbers. And P2 plus P3 and P3 plus P4, all of them. These are the numbers here, can you see? Let these numbers be, let us say this is my A, this is my B, this is C, okay, like that. Wait, yeah, so instead of writing A1 B1, so I'll be writing, let us say this is A1, this is A1, this is A2, this is
Sir, I
A1.
got it,
Yeah, how? Bolo?
but I didn't use the method we were supposed to.
Acha, let me just solve this method. Because the idea is to explain you the use of this inequality. So let us say these are all the terms. So what is the final term? Final term will be A201, sorry, P2013 plus P2014. So this is term number how much? A2013, isn't it? Now consider other terms like 1 upon P1 plus P2 and call this one as B1. Okay, and then 1 upon P2 plus P3 and call this as B2, and so on and so forth. Bn will be B what? B2013 will be nothing but 1 upon B2013 plus B2014, isn't it? So this is P, not B. I am now what Cauchy Schwarz says, that A1 B1 plus A2 B2 plus A3 B3 all dot 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 an bn, right, squared is less than equal to what? A1 squared plus b1 squared plus b, sorry, A1 squared plus A2 squared plus A3 squared plus dot 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 an squared, right, multiplied by b1 squared plus b2 squared plus b3 squared plus dot 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 bn squared, isn't it? Am I right? Or no, sorry, yes, this is an inequality, right? So hence, to beat it, what I can do is okay, a1 square it is right now. So so what can I do is a1 square plus a2 square plus an square. Okay, now instead of that, what other thing which I can do is I can say, let this be roots be the terms, all roots. Okay, why am I doing this? You will get to know quickly. So let us say if the roots are there, then if you multiply the a1 and b1, what will you get? You will get 1, isn't it? Similarly, if you multiply a2 b2, you'll get 1. You get a3 b3, you'll get 1. So hence I can say in the left hand side it will be 1 plus 1 plus 1 plus dot dot dot. How many? N is nothing but 2013. So it is 1. 2013 ones are there. So this square, okay, and then on the left hand side a1 square is what? P1 plus P2, isn't it? And A2 square is P2 plus P3, isn't it? And likewise, AN square is P2013 plus P2014. And this multiplied by what? 1 upon B1 square is P1 plus P2. And then plus 1 upon P2 plus P3 plus dot dot dot. It is 1 upon P2013 plus P2014. Is it okay? Right. So on the this thing you'll get 2013 squared. Right? 2013 squared is less than equal to, I am writing P1 plus P2 times, sorry, plus P2 plus P3 plus dot 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 P2013 plus P2014 multiplied by 1 upon P1 plus P2 plus P1 upon P2 plus P3 plus dot 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 1 upon P2013 plus P2014. Isn't it? Now, if you closely look at it, what can I say about this? So hence I can say 2013 whole square divided by, let me take this item on the left hand side. So what is the left hand side thingy? So this will be 2013 square divided by P1 plus P2 plus P2 plus P3, so on and so forth, plus dot 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 P2013 plus P2014. Okay, and this will be less than equal to 1 upon what is it, 1 upon P1 plus P2 plus dot 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 1 upon P2013 plus P2014. Guys, am I right? So far so good. So hence if you see the what is the denominator of the left hand side, if you closely see, this is nothing but 2013 square. Now I'm only dealing with LHS, guys. Okay, so LHS 2013 square, and this is nothing but every item is 2 times, but P1 and P2014, isn't it? So hence can I not write this as 2 times P1 plus P2 plus dot 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 P2014 minus P1 minus P2014, isn't it? Yep, because every item was 2 times. So hence I can write this. Right. Now what is P1, P2, P3? Basically it is an AP, isn't it? 1, 2, 3, 4 till 2014. Isn't it? So what is it? Nothing but 2013 squared divided by 2 times sum of an AP is number of terms 2014 divided by 2 into number of terms plus 1. Isn't it? Minus P1 minus P2014. Okay. Isn't it? So that means this is nothing but this 2 goes. So it is equal to 2013 squared by 2014 into 2015 minus P1 minus P2014. So far so good. Now if you see this item P1 and P2014, right? So what is, if I increase the denominator, then the value goes down, and if I decrease the denominator, then the value goes up. So this particular value is this particular value is greater than equal to, I am saying 2013 square divided by 2014 into 2015 minus 1 and minus 2. Why is this so? Because 1 and 2 are the least of the all 2014 numbers, right? So this particular, so here if you see the numerator is same, but the denominator on the left hand side is lesser than denominator on the right hand side. Is it okay? Right?
Yes, sir.
So yes. So what can I now say? So hence now okay, so then what? Okay. So this must be greater than equal to this must be, now again I can simplify this, and what can I say about 1, or rather what I could have done is, yeah, so I can remove one more. So this must be greater than equal to 2013 square 2014 times 2015 -1 -1. So I'm reducing the denominator further, isn't it? Did I do this correctly? Am I am reducing the denominator. No, I'm increasing the denominator. Actually, I added 1 in the denominator. So hence the right hand side will go down, isn't it? The denominator is increasing. Now this item can be written as 2013 square divided by 2014, 2015, and minus 1 can be written as 2014 minus 2015, and -1 can be left as it is. Now this is on purpose. Why? This is now 2013 square divided by, I can take 2014 common from what? From, yes, so this is 2014 common, and I can write this particular expression here can be written as 2015 -1 and 2015 plus 1. Am I right? Yes. This is a factorization, isn't it? So it is basically nothing but 2013 by 2016, which I got the answer as. So basically this is less than the given problem statement, and this is what we have to prove, isn't it? What was it? Oh, sorry. So we had to prove that this is, where did I start? Yeah. So the 2013 by the 2016 is less than all that activity which we did. So this is all the other terms are more than this. So hence proved. Okay, so you'll have to do a lot of mental exercise to get to the solution. It's not that simple like, other your syllabus, 10th board syllabus, that you apply the formula and you get it. You have to think through, and you have to work on lot many steps to eventually find out the solution. And the only way out is not me solving the problems, but you guys solving the problems. Yes, keep those tools in mind so that whenever you require them, you can use them. But ultimately, your thinking process only will decide whether you're gonna be able to solve the problem or not. Okay, so I hope we are good. We are done with inequalities. This much knowledge is good enough to clear RMO, I think, in inequalities. Later on, now from next class, we'll be having some other topic. Okay, so I'll be sending some problems for you. Please solve, and let's see if and those inequalities, now try and solve those questions. And you must solve at least one question on a daily basis. Otherwise, there is it will be very difficult to catch the pace. Okay, fair enough, guys. So let's call it a day. All the best. Bye bye.
Thank you.
Bye, sir.
Bye.
Thank you, sir.
Bye.
Bye, sir.
Bye.